Lab 10 has been designed to acquaint you with a technique called titration. So we're going to do the following reaction where we slowly drip in some sodium hydroxide, which of course is a base, to some hydrochloric acid, and this is a neutralization reaction. So that's one way we might classify it. In a neutralization reaction, we always get as products salt, a salt, and water. In order to figure out what we're going to get, we could also treat this reaction like a double replacement reaction. We looked at these earlier in the semester, and in a double replacement reaction, we basically get the cation and anion partners to switch. So that means Na will potentially bond with Cl, and that gives us our salt. And then H and OH come together, and that's where we get our water. So this is the reaction that we're going to do, and the goal of the experiment is to determine how concentrated the HCl solution is. So we want to know the concentration of the hydrochloric acid, and more specifically, we want to know the molarity of the HCl solution. And this is generally the reason why you would do a titration. You do titrations usually to figure out how concentrated something is by using a solution with known concentration. So that's the case in this lab. We know how concentrated the sodium hydroxide is, and we're going to add it to a hydrochloric acid solution with this goal in mind. So let's look at the reaction and how it is set up using a piece of equipment that I think will be new for this lab. So a long glass tube called a burette is where you're going to put your sodium hydroxide solution. We know how concentrated it is. It has been prepared to be 0.1 molar. So that means there are 0.1 moles of sodium hydroxide in every liter of solution. You will put your acid into this Erlenmeyer flask, so our HCl solution will go there. We don't know how concentrated it is. We only know how much we're going to use. And I think your procedure specifies that you're going to put 10 milliliters there. Whatever the amount is will be specified in your lab procedure. Alright, so this stuff looks like water. This stuff looks like water. We're making salt water. So we also have to add an indicator. We're using phenolphthalein as our indicator. And this indicator will allow us to see when the neutralization has been completed. So right now, when we add phenolphthalein, the solution will be colorless in the presence of an acid. And then as soon as we've dripped in enough sodium hydroxide to neutralize all this acid, the solution will then become slightly basic because we will have dripped in a tiny bit of OH more than we need, and the solution will turn pink. And so this is how we know when to stop titrating. And we've reached what is called the neutralization point, or the end point. So let's look at the calculations. The calculations for this lab are very simple. It's a very nice relationship. You're actually going to do the titration twice. So the first time you do the titration, it's called the course titration. You will not do any calculations really for this titration. This titration is done mainly just to get an idea of where the endpoint is. How much base do I need to get close to the endpoint? So this is just kind of like a trial run just to kind of get an idea. Once you know where the endpoint is going to be, close to where it's going to be, you go back and repeat the titration, and we call this one a fine titration. This is the one that we're going to do more slowly and more carefully, and we'll get an exact measurement from this titration. This is the titration that you're going to do the calculation for. Alright, so the formula that we're going to use can be written this way. Ca is the concentration of the acid. This is what we're looking for. How concentrated is the HCl? That can be multiplied times the volume of the acid. Specified in the procedure, I think, is 10 milliliters. You're told exactly how much HCl to use. The other side of the equation is for the base, the concentration of the base. This is, of course, the sodium hydroxide side of the equation. We know the concentration of the base is 0.1 molar. This solution has been prepared. We know the concentration of it. Volume of the base that we're actually going to use, you're going to know from doing the titration. So I'm going to talk a little bit more about this. So once we know all of these values, we can very simply solve for the concentration of the acid. It will be equal to concentration of base, which we know, times the volume of the base, which we will know, divided by the volume of the acid, which is specified in the procedure. Okay, so really the only one we need to do a little bit of work on is the volume of the base. So let's look at that a little more closely. How are we going to know the volume of the base? All right, so again, using your burette, this is where your sodium hydroxide is placed. With the fine titration, the one that you're doing nice and slow so that you can stop at the first moment the solution, the next drop that turns the solution pink, that's when you stop titrating. Okay, so let's just say that you start with 50 milliliters of sodium hydroxide in your burette, and you have, once the solution turns pink, the one drop that turns the solution from colorless to pink, that's when you're going to stop titrating. And you find that there's now 30.80 milliliters of sodium hydroxide in your burette. So the question is, what's the volume of the base that you used? You started with 50 milliliters in the burette. There's now 30.8 milliliters. Now, I don't know if these numbers are right. Obviously, you're going to use the numbers that you find. I'm just kind of making up an example here. This tells me that I have dispensed 19.2 milliliters of sodium hydroxide. I think the lab may actually indicate this as the volume of sodium hydroxide solution that was delivered. So sometimes that's the word that's used to describe how much actually came out of the burette and went into your acid solution. This is the volume of the base. So you're going to determine the volume of the base by knowing where you started and where you ended up and take the difference in those volumes. So then you'll go back, of course, to this calculation, plug that in. The concentration of the base is 0.1 molar. The volume of the acid, I think, is 10 milliliters. This will have units of milliliters too, and so your milliliters will cancel, and obviously you'll be left with a unit of molarity. Alright, so you do it once course titration, just get an idea of where to stop titrating so that you can go back the second time and do it more slowly so you get a very good reading right here. Alright, one additional piece of information that I need to leave you with, and this is the equation that we just used. I just used A's for acid and B's for bases, so you could write it like this, or you could actually use M's for molarity. These formulas are the same. I need to let you know that this formula doesn't work all the time. It only works some of the time. So when does it work? It works when you have a neutralization reaction that is 1:1. That means, in this case, 1 mole of sodium hydroxide reacts with 1 mole of HCl to give our neutralization products. really what we're saying here is the molarity times the volume is really moles of acid, which are equal to moles of base. So this will only work if the reaction is in fact 1-to-1. That means if you have a reaction that is not 1-to-1, like the reaction between sulfuric acid and sodium hydroxide is actually a 2-to-1 reaction, you would not be able to use this formula directly if it were this reaction. So you have to do a little more calculating. The details of that are described in Chapter 10. I won't get into it right now, but I just want you to know that this is very handy to use, but it only works when the acid-base reaction is 1-to-1.